Hello guys, good evening. Welcome to my channel, Chemistry Made Simple with Finola. So in today's class we are going to look at mole concept. As we all know, it is a very important topic in chemistry. We do the theory in class and it will take us through the practical aspect when we get to the lab. So let's get to it. I hope you all cooperate and make the lesson a successful one. So today we are looking at mole concept, as I said. When we talk of mole, we are dealing with substances, as we said, but we are going to look at measurement in general. So mole, we are dealing with molecules, atoms and ions. As we all know, they are the building blocks of matter. So we look at atoms, molecules and ions. They are termed as the building blocks of matter. So when we talk of the mole, you'll be dealing with measurement, and an advantage, or we'll be looking at two advantages of measurement. We do measurement for the fact that we don't use things in excess, or we don't waste things. That's the first advantage of measurement. Then secondly, we do measurement as chemists in order to help us so that the measurement will cut across, or it will be recognized worldwide. Whatever will be said here will be said all over the globe. That's it. So as we know, with the physical quantities and the stuff like that. Okay. And in this measurement, you are going to look at carbon. As we know, carbon has isotopes. We compare everything to the carbon-12 atom. Carbon-12 in the sense that it is the most stable amongst its isotopes, because we have carbon-12, but we know the atomic number of carbon to be 6. So we know that then it's going to have atomic number 6. Then the neutron number will also be 6. We know that the neutron number is the difference between the atomic number and that of the mass number. So when we have atomic number 6, the neutron number 6, it makes the ratio 1:1, and that makes it very stable. So in all our measurements, our yardstick will be the carbon-12. So the mole is compared to the carbon-12 atom. Under the mole concept, the first quantity we want to look at is the mole. So the mole of the substance, which is termed as the amount of substance. So the mole is the amount of substance which contains as many particles as there are in 12 grams of carbon-12 isotope. So that is mathematically expressed as, so that is N equals M on MR. Here we are using these symbols. We will define them so that it will be very clear. N here is the amount of substance, or as we call the mole. Then M denotes the mass of the substance. Then MR will stand in for the molar mass of the substance. So it means that the substance in question, when we want to look at the amount of substance or the mole, then it is denoted or expressed mathematically as N equals M over MR, where N is our amount of substance, which is the mole, then M is the mass, then MR stands in for the molar mass. So this is our first term, and we need to take note of our first expression. That is amount, which is N equals M over MR, where M is the mass, N is the amount of substance, and MR is the molar mass. This is how the mole is expressed mathematical. The second quantity we want to look at is the Avogadro's number or the Avogadro's constant, which is normally denoted by the letter L or N subscript A. This is how it is done. So it's either L or NA. We can stick to one of these. Good. So the Avogadro's number or constant is defined as the number of particles in a mole of a substance. And these particles or entities, as we refer to them, can be atoms, molecules, and ions, as I said in the introduction. So when you are asked to find the number of particles or the number of entities, it could be atoms, it could be ions, or it could be molecules. And this have been found already, that is experimentally, and it has been found out to be, or the Avogadro's constant has been found out to be 6.02 times 10 to the power 23. So when we add atoms or particles, depending on the question you have. So as we move along, we will take a question and look at it. 1 mole of a substance contains 6.02 times 10 to the power 23 particles. And we are saying that these particles could either be atoms, ions, or molecules. And the Avogadro's constant is also related to the amount of substance, which is the mole, and this is how they are related. It means that here, because you are going to encounter N as the amount of substance and also the number of entities, we want to drop this Na and rather concentrate on the L so that we don't get confused along the line. This is what I mean. When we talk of the Avogadro's constant, this is how it is related to the amount of substance. So the capital N here is no longer this, but rather we are referring to the Avogadro's number or constant as capital L. So this N here is the number of entities. Then our small n, as we know previously, is the amount of substance. Or simply put, the mole. And then our L comes in, which is the Avogadro's constant or number. So it means that this is how the amount of substance is related to the Avogadro's constant. So the number of entities is always equal to the amount of substance times the Avogadro's number, which has been found out to be 6.02 times 10 to the power 23. So this is how the amount of substance and the number of entities are related when it comes to the Avogadro's constant. But we want to make the number of substance or the mole the subject. And in that relation, when you want to make small n, which is the mole, the subject, then you have n equals n over L. It means that this is how the amount of substance is related to the number of entities as well as the Avogadro's constant. It means that the mole is equal to the number of entities over the Avogadro's constant. With that being said, we can move on to the third quantity. The third quantity we want to look at is what we term as the molar volume. Molar volume. Molar volume, which is denoted by capital V subscript M. But this goes for only gases. We use this equation when we encounter questions which involves gases. When we want to look at the molar volume, it means that we want to look at the volume occupied by substances per the mole. So it means that the molar volume has also been found out to be 22 22.4 dm³. That is the Vm. So we can say that the molar volume is the volume occupied by 1 mole of a gas at standard temperature and pressure. Good. And let's look at its relation. This is how it is expressed. It means that when we take the mole, it is always the volume occupied over the molar volume. So this is how it is related. So the amount of substance and the V. So let's bring these out. So N, as we know already, is the mole or the amount of substance. V is the volume of the substance. Then Vm is the molar volume, which has been found out to be 22.4 dm³, as said earlier on. And as I said, this applied for or to only gases. Gases only. Gases only. That is when we apply the molar volume. Now that we've seen all these, we want to look at the connection between them, how they are expressed, so that when we have a question, we know which one to use and which one not to use. So let's see. It means that the center of attraction here is the mole, which is N. So in our first instance, we saw that N, which is the mole, is the mass on the molar mass. That is N. The same N can also be expressed as N equals N on L. That is when we are looking at the Avogadro's constant. I hope you remember, we follow. Good. Then now, we've also seen that when we are talking of gases, the N can also be expressed as V over Vm. Now we know all these quantities. Then last but not the least, when you are looking at this, the molar mass, it goes for substances. But we can take when it's just an atom or an element. So we can say that the N is also equal to M on AR. AR is the relative atomic mass. So this one can be for just an atom or an element in question. So this is how the mole is also related to other substances. So if we should go all over, or if you want to summarize what we've learned today, then we are talking of the amount of substance which is related to all these substances. That is why we have made this simple table for us. Now in our next video, we'll be looking at questions and how we use these quantities and expressions in solving them. So the first one, the mole, was related to the mass and the molar mass. So M, mass, MR, molar mass. Then we saw the second one, which is the Avogadro's constant. We saw that N is also related to the Avogadro's constant as the number of entities over the Avogadro's constant. Then thirdly, where we are looking at volume, where we are saying that this expression goes for only gases. The mole is also expressed as the volume occupied by the substance all over the molar volume, which has been found out to be 22.4 dm³. Then when we are talking of just an element, we have N, that is the mole, over the mass or the mass on the relative atomic mass. Thank you. See you in our next video. Subscribe to my channel, Chemistry Made Simple with Finola. Thank you. See you in our next lesson. Bye.